SwayamPrabha. Digital India. Educated India.
Let us start this lecture with a thought process by great saint of modern India, Swami Vivekananda, who says that every person is potentially divine and the objective is to manifest the divinity within by controlling external or internal nature. So, this is a very important statement so far the objective of education is concerned, and our scripture always talks about that each individual has an infinite potential. So, we need to work for it to unravel this power lying within in a human being, and let us recall that what we learned in the last lecture. In the last lecture, we initiated discussion on the injection system, and we charted out the various functions of an injection system in a liquid propellant rocket engine, and later on we moved into the various components of a injection system, that is your injector head, distributor and atomizer. Later on we also looked at the processes involved during the atomization of liquid, and for that we took a example of a liquid passing through a slit or in a jet, but we more emphasize and discuss on the liquid passing through a small slit. And when it is force through a slit with certain pressure, then the liquid gets stretched and it also subjected to oscillation. As a result, the bulk liquid is separated from the from its seat or a jet, and ligaments or the liquid rods are being formed, and these ligaments are further shredded out and the droplets are formed. We call it as primary atomization, when these droplets, bigger droplets are converted into smaller droplets. Sometimes small droplet also will be coalesces to form bigger droplets, particularly when the momentum is quite low and the interaction between the aerodynamic forces and the droplet is quite less, then of course the bigger droplets can be formed. That means all sorts of droplets will be formed with a wider range, and that we call it as a secondary atomization. And in order to find out the effect, and we have defined three non-dimensional number, and one of them is Weber number, which is basically the ratio of inertial force to the surface tension force. We have seen that when the inertial force is higher as compared to surface tension force, the Weber number will be higher, and if the Weber number happens to be higher, then naturally the disintegration of the bulk liquid will be more likely to take place, and that we have seen. And beside this, the Reynolds number also plays a very important role, and that is the ratio of inertial force and viscous force. And then towards end we also defined another number which is known as Ohnesor's number. And if you recall, Ohnesor's number is basically OH, I can write down it is a ratio of the viscous force and also the root over of the inertia and surface tension force, we can write down rho sigma dj. We know that mu is basically the viscosity and rho is the density. This is the density of propellant, and sigma is the surface tension force, and dj is the diameter of the injector. So, if you look at, I can write down this as mu root over rho dj, and of course, the sigma, and if I will multiply on the numerator root over rho dj, and in the denominator also root over dj, and I can also multiply basically v over here and v over here. And if you look at this term and this term together will be basically the rho v j, I can say j is better, the velocity of the jet if I considering, and rho v dj by mu, and mu is there, and I can write down here root over dj v square divided by sigma. If you recognize this, this is nothing but your Re j, and this numerator is nothing but your Weber number, and root over of that by the Re j. So, you can see that this is basically the Weber number, ratio of root over of Weber number, and this is your Reynolds number. Of the jet, and this is if you look at, this is also known as the stability number, because that will indicate that extent of instability that is occurring in the liquid seed or the liquid jet. Ohnesorge number is basically will be indicating the ratio of the viscous force over the Reynolds number and also the surface tension. So, or the inertia force and surface tension. When the Ohnesorge number is higher, it indicates the viscosity effect is more. We will be looking at it a little later on, that how this can be related with the Reynolds number, and higher the Ohnesorge number means that a greater influence of viscosity which will be there during the atomization. So, in order to illustrate the importance of Reynolds number and also the Ohnesorge number, we will be looking at an example and look at what is happening to the atomization. We will be looking at what is really happening during the process of disintegration of liquid jet and considering a simple jet. So, if you consider this is a simple orifice, this is an orifice having diameter of d, this is your d, j is the diameter of orifice, and this is your dj. And keep in mind that if the pressure is here, in this case there will be some liquid pressure which will be applied or which will be there, and then that will be forcing the liquid to pass through. And as a result, the velocity also will be decided by the diameter of the jet. So, the velocity, as the pressure increases, the velocity will be increasing, and so also Reynolds number. If you look at, and this is the very low Reynolds number flow, as we know that rho v dj by mu, and for a particular propellant. Now, if the pressure is not much, it will be just coming as a solid liquid jet, and after that it will be subjected to oscillations, and there is a oscillation which will be there, and this is a varicose oscillation, varicose oscillation it will be there. And this is of course, when it is subjected to a gravitational pull that we had already seen, the liquid will be dripping out of the orifice. And this varicose, if you look at a wavelength, this wavelength, the lambda is the wavelength of oscillation, and that lambda will be around something approximately 4.6 dJ, and that was really studied by and put forwarded by Rayleigh, and therefore, we call this regime as a Rayleigh jet breakup, and jet is when this is oscillated, it is being broken out here, and then this will be separated from the liquid dripping from this orifice, and having a satellite droplet, the satellite droplet and with a this diameter as a bigger droplet. Keep in mind that this bigger size droplet will be always higher or on the same order of the jet diameter. Of course, now if the pressure is increased further, that means the pressure is increasing further to the next level. So, so also the Reynolds number increases. Then the what will happen, this oscillation will be closer to the surface of the orifice. This is the surface of orifice. And it is subjected to more oscillation. As a result, the droplet is separated out, or the ligaments is separated from this oscillating liquid jet, and it become a bigger, and of course, there is no satellite droplets because it is not dripping. Now, it started breaking due to the increase of higher velocity, and of course, again this size will be order of that of the jet diameter. And now, if the pressure is increased further, that means the pressure here again increasing further, and so also the Reynolds number is increasing, and the pressure is increasing further, and Reynolds number also increasing further. So, that what will happen, the velocity will be higher, and then the liquid, it will be coming as a solid jet, and it is subjected to sinusoidal oscillation, and the jet and then this will be thinning down of the liquid jet, which will be occurring leading to the separation of the liquid from the bulk liquid jet, and this is basically known as the ligaments. Ligaments are being formed, and this ligament is subjected to further shredding, and then it will be smaller droplets will be formed. And these droplets, of course, again the size will be similar to the jet diameter, and it will be dictated by the jet diameter, and it will be of course little bit smaller than the when it is in the Rayleigh jet breakup regimes. And here in this case, there will be some kind of entrainment air, or the ambient air entrainment of ambient gas will be taking place, and therefore, it is known as the wind induced breakup, because the breakup is basically dictated or influenced by the entrainment of ambient gas or a gas is entering into that. And when the pressure is increased further, again pressure is increased further, then the jet breakup length is little bit reduced. This is known as jet breakup length. This length I can say Lj, and in this case again the droplet size will be of different kinds and then varieties, and then there is a more oscillation in the jet itself, liquid jet. And when the pressure is increased further, the Reynolds number also will be increasing. Reynolds number of the jet will be increased, so also the velocity. So, Vj also will be increasing, and when this Vj increases, this oscillation will be start very closer to the orifice surface, and then of course, the ligaments are formed and then it will be going. And with further increase in the similar cases will be happening that this has been reduced, this length is being reduced, and Lj is being reduced, and then it will be subjected to oscillations, and then the ligaments are formed. And during this time, of course, these will be little lower size will be coming, because the secondary atomization which will be playing a very important role here due to the induced wind velocity, and a lot of interaction will be taking place, so that there is a very wide range of droplets will be formed. And when the pressure is increased further as compared to the wind induced breakup regime, then the jet breakup distance is also reduced further, and there is a started also searing of the liquid surface. That means, some of the ligaments are basically coming out of this, and then this will be again subjected, and secondary atomization will be predominant. And when the pressure is increases further, the atomization will start from the exit of the orifice itself. So, there is no distance in which solid jet will be maintained, and in this case the primary atomization, secondary atomization will be very vigorous, and it will be starting from the very beginning. And keep in mind that there is the relative velocity between the liquid jet, the Vj, and also the V gas will be higher. As a result, the droplet size will be not dictated by the diameter of the liquid jet, rather it will be very smaller range. In other words, average diameter of the spray will be much lower as compared to the liquid jet diameter. And this is as I told earlier, the relative velocity between the jet and also the gas or ambient gas will be much higher. So, the atomization is quite good, and then this is the case which will be dictating, and it also occurs in a certain cone. So, this will be having some cone, and this will give you uniform droplet distribution as compared to the second wind induced breakup or the first wind induced even. Therefore, it is important to have a atomization regime for to get a better spray, particularly in the rocket engine application. So, let us look at the Rayleigh that how does it affect that, that is the your Owen's surge number, and this is your Reynolds number is being plotted here. And if you can see that the Rayleigh regimes will be occurring here. That means, even if Reynolds number is low, the wider range of Owen's surge number, the Rayleigh mechanism which will be occurring, and of course, when the Reynolds number is a little higher, then the first induced regime will be occurring. Keep in mind that, and as a lower Reynolds number, this will be occurring at a very higher Owen's surge number. and whereas the higher Reynolds number, this regime first induce, even the second induce, even the atomization will be occurring, particularly first and second induced will be occurring at a lower Weinstein number. And of course, atomization which is the need of a basically atomizer or a injection system for rocket engine applications is a wide range of Weinstein number, and Reynolds number will be much higher as compared to Rayleigh mechanism. So, we have seen 4 stages of a liquid fuel disintegration, a simple orifice, and of course, one can go for a little complex one, but keep in mind that we use a simple orifice in case of a rocket engines, and we will be also using the other method of enhancing the atomization process in case of rocket engines. So, question arises, what are the basic methods of atomization in injectors used in rocket engine? We can classify into 2 categories. We use the pressure such that we will get a higher velocity through an orifice, and then that will be really forming the ligaments due to the searing of the bulk liquid, and also particularly at a high pressure atomization will be good. But suppose you want to have a little lower pressure, but you want to have a better atomization. The other way is that you impinge the little low velocity liquid as compared to the non-impinging atomizer. So, therefore, we can broadly divide into 2 categories, one is non-impinging atomizer, other is impinging atomizer. In impinging atomizer is basically liquid momentum is being used to advantages such that it can be broken directly without really undergoing the changes due to oscillations. Of course, the impinging may be leading to some certain oscillation of the process. So, question arises then, what are the processes occur during impinging liquid jets? Let us consider that, and we will consider 2 liquid jet A, which is shown here, and the liquid jet B. One can be fuel, other can be oxidizer, or it can be both, either the oxidizer and fuel stream, both can happen. So, when they are impinging on this point, this we call it as the impinging point. And if you look at the pressure at this point will be very high, because the velocity will be coming to almost 0, and then the liquid will be trying to go down, provided that they are impinging with the same momentum. If there is a difference of momentum between the 2 liquid jets, then naturally it will not be in the same place, it may be swayed away depending on whose momentum is higher. Now, if you look at this is basically a liquid seat, you can look at this is a liquid seat, but you can't see from here, and when you look at the perpendicular to this, or you look at the side view of this, that you will be getting into a flat seat, that is the seats, and as I told, this is a very high pressure zone, high pressure zone here, and that will be dissipated, and because of that this liquid will be seared and thinning down, and then this we call it as basically fan liquid seat. And when this fan is occurred, then it will be searing down towards end till its momentum is dissipated. As a result, these ligaments, these are ligaments will be separated out from this fan and the various regimes, and then these ligaments will be undergo the secondary atomization, maybe by impinging, colliding to each other or to coalesce, and then there is some ligaments are also formed here, and then smaller droplets. So, look at these are the basically droplets, one can say that this is the droplet and this is the droplets, and of course, these are ligaments this is being occurred in an impinging atomizers, and this can lead to the oscillation, because there will be some wave which I have not shown here, and such that it can really occur. And the seat formations can really take place in various ways, and in case of impinging atomizer, the fan seat is being used, and whereas in case of an atomizer or a non impinging atomizer, and we can look at basically, let us say this the liquid is coming out and there is a orifice here, and this is, we can say, the nozzle or orifice. Then the a liquid cone can be coming out, provided it is being forced together, or it is maybe tangentially, or the swirl being imparted. So, this is basically the conicals, this is basically conical seats which will be formed, and then this will be ligaments will be rippled out, and then it will be threaded out kind of thing. These are threading which will be occurring, and then these are ligaments can be formed like ligaments, and then droplets can be formed over here, and depending on, and flat seat we have already seen that if you drop certain liquid from here on a surface, let us say this is your surface which is there, and then in your dropping over a let us say this is your liquid, and then this is a form, this is your liquid seat, flat seat, liquid flat seat, and therefore, there will be some kind of a is being formed, provided provided that height is more, or you are dropping the liquid at a higher velocity, and because of the Weber number will be more. So, inertia forces will be more as compared to the surface tension. So, therefore, the ligaments and the will be formed, and so also the droplets. And this is your flat seats, what will be getting this. So, therefore, this is the basic principle which we will be using, and in the next lecture we will be discussing about the types of injectors which are being devised, and we will be discussing some of them in the next lecture. Thank you very much.